So ammeter negative to anode of photocell. Now after that, take one more connection from negative terminal of the battery to cathode of photocell. So connect negative terminal of battery to cathode of photocell. So these are the connections for photocell experiment. First, switch on the power supply. Now illuminate that photocell with a light source, and this is the current 0.59 at 0 volts. So voltage is 0, current is 0.59. So note down these two values in the table in forward bias side. So anode potential is 0, and current is 0.59. After that, change the potential value with the rheostat. So change the potential by using a rheostat. Now it is the voltage value 0.51, and this is the corresponding current value 0.76. So with the increase of potential, photocurrent is increasing. So that is what is the condition for forward bias. Next, increase the potential and note down the photocurrent similarly. Next, reverse bias. For reverse bias, so just invert the connections of the power supply, and again note down the current at 0 volts. So at 0 volts, the current is 0.54. Next, increase the potential in reverse bias, that is now place the potential at 0.05 and note down the corresponding current value at 0.46 potential, current is 0.40. Means with the increase of potential, current is decreasing. So that is the condition for reverse bias. Now at a particular value, so we are increasing the potential, but current is decreasing, and at this particular point, that is at 0.179 volts, current becomes equal to 0. So this particular voltage is called as stopping potential. Now take voltage on x-axis and current on y-axis, and draw the graph between voltages and currents at one intensity. So this is the curve obtained with intensity I1, and this is forward biased side, and this is reverse biased side. Now change the intensity by changing the position of light, and again do the same thing, and this is the curve for I2. So this is another setup for the photocell. So first of all, place in DC side, and all these are internally connected inside the kit. So only we need to connect voltmeter, ammeter, and photocell. So at first connect voltmeter positive to ammeter positive. Next, after that, ammeter negative to photocell positive. So ammeter negative to photocell positive. Next, photocell negative to voltmeter negative. So connect negative terminal of the voltmeter to cathode of photocell. Now switch on the power supply and change the voltages by using this knob, and note down the corresponding currents in the ammeter. So in forward biased condition, current increases with the increase of voltage. And next, to put this circuit, so this is values for current for different voltages. So with the increase of potential, our current is increasing, means it is in a forward biased condition. Now, in order to put the circuit in reverse biased condition, so invert the both connections of voltmeter and again increase the voltage and note down the corresponding current. And the dispersive power of a prism. So the aim of this experiment is to determine the dispersive power of a given prism. Operators are spectrometer, prism, mercury vapor lamp, etc. And this is the formula. Refractive index of a color mu is equal to sin A plus dm by 2 by sin A by 2, where A is the angle of prism and dm is the minimum deviation coefficient. And this is dispersive power. Omega is equal to mu 2 minus mu 1 by mu minus 1. And this is dispersion of light after passing through prism. So white color light splits into 7 colors. This is the tabular form for dispersive power, consisting of color of spectral line, left side readings. So this is the table for dispersive power. So this is the first table for the measurement of angle of prism, and this is the second table for measuring dm values for different colors. So this is the operators: mercury vapor lamp, spectrometer consisting of telescope, prism table, and collimator. So this is the prism table, and this is the scale. This is the other scale. So spectrometer consists of 2 scales. And this is the prism. And this is a light source. And at first, focus the telescope to a distance object and adjust the rock and pin iron screw until you get a clear image. So change the position with rock and pin iron screw and observe through telescope until you get clear image. After that, open the shutter of collimator. So first open the shutter of collimator and rotate the screw, and at first open the slit completely. So first of all, open the slit completely and place the collimator in front of the light source and observe the slit through telescope. Now adjust the screw of collimator until you get a clear slit. After getting a clear slit, so decrease the width of the slit. So convert the slit into very narrow slit. Now this is the prism consisting of different sides. So 2 sides, very smooth sides, and another side, that is so this is the rough side. Okay, first of all, place a rough side of the prism towards the telescope. Now we can't get any slit through the telescope. Why? Because rough side is towards the telescope. Now rotate the telescope until you get a slit, and coincide the slit with a vertical crosshair and take the reading on the scale. Now note down the reading of the position of telescope, that is on left side, which is 93.5, and this is the vernier coincidence reading. Next, after that, rotate the telescope on the right side. Again, change the position until the crosshair coincides with the slit. Now again, note down the reading of the telescope position on the same scale. So note down the reading. So that is 337 and vernier coincidence is 24. Now this is left side and this is the right side, and difference between those two gives 2a. So that is 2 into angle of prism. After that, a means 2a by 2 gives angle of the prism. Now rotate the prism table slowly until you observe the 7 colored spectrum